Hi there, and thanks for coming back to Rithmetic with Ron. Today, we are going to work through problems where we're dividing decimals and whole numbers. I'm going to unpack that and show you how. Go ahead and hit subscribe and enjoy the video. Let's start today's lesson with a quick review of the parts of a long division problem. 10 divided by 5 is 2. Okay, we're going to label these so that we remember. Underneath the division bar, you have the dividend. Outside of the division bar, you have the divisor. And then up top, your answer is called the quotient. How could I rewrite this problem as a fraction? That's going to be helpful in today's lesson, and so we're going to look quickly at what this problem looks like if I write it as a fraction. And here you see that the dividend is the same as the numerator of a fraction. The divisor is the same as the denominator, and the quotient is your answer. If you need to pause and write this down on a piece of paper, it's going to be helpful in today's lesson. Now let's go ahead and get into the 3 different types of problems that we have when you are dividing with decimals. The first type of problem has a decimal on the inside and a whole number on the outside. This is the easiest kind of problem because dividing by whole numbers is a little bit more intuitive, and all we need to do on this problem is move the decimal point straight up into the quotient. We're going to treat the decimal like a number and say that it has a place value. Recall that in a number like 102, we have ones, we have tens, and then we have hundreds over here. If I were to add the number 23, if I don't keep my ones and my tens in the proper place, I get a wrong answer. I have to keep the ones together and the tens together to get the right answer. The same thing is true with the decimal. You need to keep the decimal in the same place, and then you know that your digits will not be off by 10. So let's go ahead and do this problem. Once we have the decimal in the right place, we're going to do this problem as if it was just whole numbers. And so in your mind, you're thinking 39 divided by 3, because you've already taken care of the decimal. Now you just need to do the problem and keep all of your digits in the proper place. 3 goes into 3 one time. 3 times 1 is 3, and we subtract and get 0. And then we bring down the 9, and 3 goes into 9 3 times. 3 times 3 is 9. We subtract, and we have no more digits, and we have 0 at the end. So this is our final answer, 1.3. Again, we got that by moving the decimal straight up into the quotient. And since we have a whole number outside, we can move the decimal and then just treat the digits as if they were whole numbers. Moving into the second example, what happens this time if we have a decimal on the outside? 24 divided by 0.6. Well, this is a little bit more difficult to think through because most people are not comfortable with dividing by partials. If I asked you to do 12 divided by 6, most people can think through that, and they say, you know what, 12 divided into 6 groups, I know that there's 2 in each group. But what if I ask you to divide 12 by 0.6? I'm asking you to take a whole number and to divide it into a partial. And for a lot of people, that doesn't quite make sense in their mind. So what we're going to do today is we're going to convert this outside number, the divisor, we're going to change him into a whole number so that we can more easily work through this problem. Now, how do we do that? When you divide 2 numbers, you can move the decimal point in the same direction, the same number of spaces. Now, can we really do this? We can, and I'll show you why. This is not Rithmetic Ron's ridiculous rules. No, there's actually a reason why we can do this. And let's go back to what we talked about at the beginning. I'm going to take this problem and I'm going to write it as a fraction. 24 divided by 0.6. Now, if I move the decimal over one place, what I would have is 6, and I would have 240. That's if I move the decimal in each of these numbers to the right by one space. How can I do that? Let's take a look at this problem as a fraction, and if you've seen my fraction videos, you'll recall that there is a term called a special one. You can take a fraction and multiply it by 1, and it doesn't change the answer. It does, however, change the form. So if I multiply the top, 24 times 10, I get 240. And on the bottom, 0.6 or 6/10 times 10 is 6. And that's what I have here. Now, the answer to the original problem, 24 divided by 0.6, and the answer to 240 divided by 6 is the same. And you can check that if you want to in a calculator. But right now, we have not broken any rules of math. We've multiplied by 1, we've changed it into a different form, and now we can do the same problem as a whole number. I'm going to erase this real quick and write it just a little bit bigger so that we can see. 6 into 240. 6 goes into 2 0 times. Bring down the 4. 6 goes into 24 4 times. And since we have a 0 left over, we can add it to the top. So my answer is 40. The decimal point was here, and so if I move the decimal point straight up and all of my numbers are in the same column, then I really don't need this 0 in the hundreds place. And what I have for an answer is 40. You can check that in a calculator quick, and you will see that that answer and this answer are the same. And again, we did that by moving the decimal in both numbers, the same direction and the same number of spaces, until we had a whole number for a divisor. Let's go ahead and take a look at a third example. And this one is where we have decimals both inside and outside of our long division. So our dividend is a decimal, and our divisor is a decimal. Well, this one can use the same rules that we learned before. We know that we can move a decimal on both numbers as long as we move in the same direction and the same number of spaces. Let's go ahead and do that. 24 97.2. We also now have a whole number as a divisor, which means even though we have a decimal inside, we can use the rule we learned from the first problem and just carry that decimal point straight up into the quotient. And now we can do this problem as if it was just whole numbers because we've taken care of the decimal. 24 doesn't go into 9. Bring down the 7, but it does go into 97 4 times. 4 times 24 is 96. I subtract and I get a 1, and I bring down the 2. Now, can 24 go into 12? It can't. So I'm going to put a 0 here. And now I need to add a 0 as a placeholder, and I'm going to bring that down. And I say 24 can go into 120, and it goes in 5 times. 24 times 5 is 120. And so when I subtract, I get 0 left over. I've used all my digits, I have nothing left over, and so my final answer is 4.05. And if you check this with a calculator, you'll see that that's not only the answer here, but if you check this in a calculator, it's that same number. And we did that by remembering that you can move the decimal point in the same direction, the same number of spaces for both numbers. And once you get to a whole number, then you can look inside, move your decimal up, and just treat it as if it was all whole numbers because your decimal is in the right place. Okay, I know that was a lot of material, but you can do this. Let's go ahead and review real quick what we learned. The first type of problem was one where we had a decimal on the inside and a whole number on the outside. Remember that if you move that decimal straight up and treat it like a placeholder, keep it in its right column, then you can just do this problem as if they were all whole numbers. That was the easiest one. The second type that we had was a decimal on the outside and a whole number on the inside. Remember that we said when you're dividing numbers, you can move the decimal point, but you have to do it on both numbers, and you have to do it in the same direction. A real quick note about that. You can move the decimal point as many places as you need to get a whole number on the outside. So here I need to go 1, 2, 3. That means I need to go 1, 2, and 3. And so take your time when you're moving the decimals. It has to be on both numbers, and it has to be in the same direction, and it has to be the same number of spaces. 3, 3. The third type of problem we had was when there was a decimal on the inside and on the outside. Okay, so let's remember what we're going to do here. We can move the decimal point as long as we move it the same number of spaces in the same direction, and we have to do it to both numbers. And this would look like 16 into 48. One other thing that we want to review quick, I thought might be helpful, is a couple of don'ts. All right? Things that you cannot do. 1.6 into 24. You cannot move the decimal and then leave the inside number alone. Here, I moved the decimal on the divisor, but I didn't do anything here. Okay? This is not equal to 16 into 24. You will get the correct digits, and the decimal will be in the wrong place, which means a wrong answer. Another thing that you cannot do is move the decimal point 1 space here and 2 spaces here. I moved it 1 space and 2 spaces. This is also not going to give you the right answer. And so let's remember, we need to move it the same number of spaces in the same direction, and we have to do it for both numbers. We cannot just do it for one. Let's look at another example where I have a couple more digits. 21.0. Okay? Look at how many digits I have out here in the divisor, how many place values of 0 between the decimal and the 7. If I rewrite this, 21.0, which I don't need the 0, but I'll leave it in there for illustration, and divided by 0.007. Now to get a whole number, I need to move 1, 2, 3 decimal places to get a whole number. So I need to multiply by how much? By 1,000, because 1,000 has 3 zeros, 3 spaces. That means I need to do the same on the top. This is a special 1, and so my answer is 21,000 divided by 7. I know this is a bigger set of numbers, but this is helpful if you run into these kinds of problems. You can see that what we did still works. you need to move both of them the same number of spaces. And here, the number of spaces that you move the decimal is the same as the number of zeros in your special one. Let's review what we just learned today. First of all, we can write a long division problem as a fraction and vice versa. The next thing we learned is that when working with decimals, when we divide, what we really want is a whole number as our divisor. That's the number on the outside. And you can do this by moving the decimal point, but there's three things to remember. The decimal point has to be moved the same direction, the same number of spaces, and for both numbers. Hope you enjoyed the video. Go ahead and hit subscribe, and we'll see you next time.